So in this video, I'll go through the process of explaining how to come up with the name for the molecule shown. So the key thing is identifying your parent chain, and recall that a parent chain is the longest continuous chain of carbon atoms. And so one tip or trick that I like to use is if you take your pen, pencil, finger, whatever you want to use, and go across each carbon atom, as long as you don't have to lift up to get to the next carbon, you are on a continuous chain. And so each point at the end of each line represents a carbon. So I could say 1, 2, 3, going from left to right, but you always want to check to see if you can get more. 1, 2, 3, that's the same. 1, 2, 3, 4, 5, and you're just working your way from one end point to another. But then you want to check to see if you can get more. And if I go straight across, I have 1, 2, 3, 4, 5, 6, 7, 8. So that accounts for my parent chain. Because it contains 8 carbon atoms, I have to use the prefix for 8, and recall the prefix for 8 is oct. I only have single bonds, meaning that this is an alkane, so it ends in A-N-E. Once we know we're dealing with octane, we can then identify any substituents, and recall a substituent is simply a group of carbon that are branching. And so the part that's highlighted in yellow represents my parent chain. Anything sticking out of that area represents a substituent. And so I have this one bond sticking off that has 1 carbon, so that's 1 substituent. I have this 1 bond or branch sticking off with 1 carbon that represents another substituent. And then here I have 1 branch sticking off of my parent chain, although it contains 2 carbon atoms, but that still represents 1 substituent. So to the left, this 1 substituent, 1 carbon, remember the prefix for 1 is meth. The YL lets us know it has 1 less hydrogen than what the methane and alkane would have. The substituent to the right, also 1 carbon, so it also represents methyl. But then the substituent at the bottom, it's 1 substituent, but it has 2 carbon atoms. Prefix for 2 is eth, so it becomes an ethyl. And so then recall we have to indicate where things are located. So we have to number our parent chain. You want to number your parent chain. If it helps starting out, number it in both directions. And when we're numbering it, we're simply saying we're numbering from 1 up to however many carbon atoms. So because this was up, then we know that that means 8 carbon. So we're just numbering from 1 to 8. So from left to right, I have 1, 2, 3, 4, 5, 6, 7, 8. If I were to count from from right to left, I would do the same thing. This would be 1, 2, 3, 4, 5, 6, 7, 8. So I have right to left, I have left to right. And so left to right, I have to indicate where all 3 substituents were located. Regardless of whether or not they're on the same carbon, different carbons, or regardless of where they're at, I have to indicate where all of my substituents are located. So from left to right, that first methyl was on carbon 2, that second methyl was on carbon 2, and then my ethyl was on carbon 3. So I have substituents on carbons 2, 2, and 3. From right to left, my ethyl was on carbon 6. I had the methyl on carbon 7. And then I had another methyl on carbon 7. And so when you come up with these numbers, if it's easier to just add them together, that can help you with determining how to determine the direction to count. So 2, 2, and 4, if you add those together, you end up with 7. 6, 7, and 7, if you add those together, you get 20. When you're numbering, you're looking for the lowest number. So we really could have just looked at the fact that we have 2 versus 6. And that tells us that we want to number from left to right. So that means that this methyl is on carbon 2, this methyl is on carbon 2, and your ethyl is on carbon 3. So now we're ready to put everything together. But because we have 2 of the same substituents, even though in this case they are on the same carbon, that won't always be the case. But the fact that we have 2 methyl groups, instead of saying 2-methyl, anytime you have 2 or more of the same, you have to use those prefixes di, tri, tetra, so on and so forth. So because I have 2 methyl groups, instead of saying 2-methyl, we simply refer to it as dimethyl. So dimethyl tells me that I have two of those groups. I would have to indicate where they're both located. So whenever you have di, that means you have two of whatever that substituent is. So in this case, that one carbon substituent. And then I have my ethyl group. Ethyl, I only have one of them. So again, eth means I have two carbon. So when I look at all of my carbon atoms in this molecule, if you go through and add them all up, you have a total of 12 carbon atoms. So your name, once we put everything together, should account for those 12 carbon atoms. So meth is 1, but we have 2 of them, so that accounts for 2. Eth is 2, so now we've accounted for 4. And then we have oct, which is 8, so we've accounted for those 12 carbon atoms. So you have your dimethyl, you have your ethyl, you have your octane. Now you have to put it all together. When you're putting it all together, you have to put your substituents first, followed by your parent chain. When you're naming those substituents, you have to put them in alphabetical order. So if I go back for just a minute to the different substituents that we had, we were looking at meth, and we were looking at ethyl. So even though we had dimethyl, the actual name of the substituent is methyl. So we're looking at the M. The actual name of the substituent is ethyl. So we're looking at the E. So dimethyl, the di just tells me that I have 2. So it tells me how many. But the name of the substituent is what you're using when you're determining alphabetical order. So I have to use the M for methyl versus the E for ethyl. And so, of course, E comes before M. So that means that ethyl is going to be first. So I don't want to just put ethyl, but I have to indicate where was that ethyl located. And it was located on carbon 3. And then I had the methyl group. So then I'm going to have my dimethyl because I had 2 of them. Even though they're both on the same carbon atom, I have to indicate that they're both on carbon 2. So you don't want to put just 2 dimethyl. You have to indicate where they were both located. And then I have my parent name. And so this is how you come up with the name 3-ethyl-2 2-dimethyloctane. So I hope this helps. If you have any questions, please let me know. Thank you.